And the webinar AI problem solving, how machine learn to think. It's a complementary webinar to the second online chapter, AI problem solving. So before we begin, I would like to know if all of you hear us clearly. I think yes. Okay. So, dear participants, we appreciate your dedication to the online chapter and to your engagement to the webinar. We hope that you have completed the second online chapter. I have seen a question in the platform and in my professional email. Um, so I wanted to let you know how it's important that you complete the online chapter before you attend the online webinar. So thank you for taking the time to participate, and we look forward to your continued engagement. So in this chapter, the second one, while AI classic model define state and the transition can be helpful for gaming, for planning, for search problem, applying them to complex real world application or problem is something different, is very challenging due to the vast number of possible states and unpredictable outcomes that can come at the time. So they are unpredictable things that we cannot cover with classic AI algorithm. So to better handle a real world scenario, this model must incorporate uncertainty, probability, odd, and this is the topic of the chapter 2. I hope that the topic of chapter 2 was very helpful to all of you, and let's deep in our understanding with our speaker. So let me introduce our speaker for today is Dr. Sukriti Bhattacharya. Is a senior, sorry, yeah, is a senior research scientist at the Luxembourg Institute of Science and Technology, LIST. He holds a PhD in computer science from Ca' Foscari University of Venice, Italy. Before joining LIST, he contributed to groundbreaking research as a research associate at esteemed institutions such as University College London, the University of Bordeaux, and Carnegie Mellon University MIT program. So with a strong foundation in applying theoretical knowledge to real-world challenge, his area of expertise includes software engineering, static program analysis, formal method, artificial intelligence, blockchain, and malware analysis. So we are honored to have him here to share his knowledge and insight with us. So during the presentation, if you have any question or comment, you can start putting your question in the chat. So we will be monitoring the chat and replying your question after the talk to our speaker during the Q&A session. Our speaker will be presenting for 45 minutes, followed by Q&A session for 15 minutes. We will do our best to answer as many questions as possible within the allocated time. So finally, so we will be recording the webinar for those who are unable to attend today's talk, or for those who want to rewatch it later. So the recording will be available on the website after the presentation. So without further ado, I would like to to turn the microphone to our speaker, Dr. Sukriti. The floor is yours.
Okay. Hi, everybody. Welcome to the second chapter. And this chapter, we will study. We will know how human intelligence is different from artificial intelligence, and we will go further, and we will establish a path from the naive to semi-expert, because you have other sessions or chapters later, and I hope this foundation will help you to understand those sessions. So first, we will try to understand the difference between human problem solving approach, like the way we solve problem using our brain, and the AI problem solving approach. So to describe it, I kind of categorize the entire comparison in in 5 categories: learning, speed, creativity, memory, and decision making. Learning, so now we compare both. Okay, so learning is like, for us, for human, learning is experience and intuition based, and it's like, from your childhood you learn something from your experience, and you use your learning progressively through your experience and intuition. But the AI learning approach is completely different. It's based on the data and the algorithm to deal that data. And that's why our learning is kind of slower but adaptable. Slower in that sense is like, you cannot study 24 hours. Your brain will not support it, right? So our learning speed is adaptive and slower. But in case of AI, it's fast because it depends on the computation power and the algorithm you are dealing with. So it's fast. It can run entire day, entire week, entire year, entire month if you have the proper infrastructure. And it is rigid in that sense that its learning is surrounded by the data you provided, the algorithm, the way the algorithm is written. So it has less creativity. The next point is creativity. So for us, we are very human are creative, right? So human can create stuff out of the box without any support if you have creativity, if you have imagination. But in case of AI, everything is depending on the data you are provided. But you can question me, like, there are generative AI that are creative, they are generating art and all, but still it is rigid and it is limited to certain extent the data it has. Okay, so that's why different AI model perform differently. Right now you have lots of generative AI models available in the internet or in the market, but their creativity is different because the way the model was trained is different. The data is different. The memory, of course, we are forgetful and prone to bias. We are forgetful means, suppose you started something 10 years ago, you cannot remember it. I mean, if you remember, still it's not that strong remembrance, right? But in case of AI, it store vast amount of data and there is no fatigue. It's so obvious, right?
Sukati,
Yeah.
excuse me. Can you hide the the sharing button, the sharing message down there? Some people
Yeah.
can't read the.
It's
Yes,
okay now?
perfect. Yeah,
Yeah.
thank you.
And the final one is the decision making, and that is the most discussed topic right now, about the ethical concern of AI. So that's why each and every European or globally countries have regulations, because AI's capability is boundless. Again, it based on data. That's why it has less emotion, and it's logical and statistical. But in case of human, it is ethical and conceptual. Okay, so this is the basic difference between the thinking approach, the problem solving approach of AI and human. And here are some example. So in case of data driven approach, so suppose we all watch Netflix and other OTT platforms, and we have a recommendation system. Even in Amazon or other marketplaces, we have recommendation system that runs with the data and the pattern, the trained analysis and all this kind of stuff, and AI. But before, when we had no OTT, we used to discuss about the movies, right? So that is the difference between human and AI. In case of trade market, the AI algorithms are very fast. They can take fast decisions, but in sudden changes in the data or in the situation, it collapses. So that's why it is not trustable 100%. In case, in comparison to human, like still the financial analysts are the most of the highest paid jobs, because they have that experience, they learned it, they saw ups and downs of the market. So they are kind of a valuable asset for the company. So you still need human intelligence to deal with such kind of situations. For creativity, you have lots of tools and models available, right? Like DALI 2 and Mid Journey and other stuff. And you have human artists. So the main difference is again the creativity. So the creativity of the AI tools or models depends on the prompt engineering, the way you are giving them the instruction. But human mind is limitless. Basically, the imagination or creativity part. And again, the decision making and the memory, we like Google, like it has an AI engine, and it based on natural language processing and all other stuff, pattern recognition and everything. It gives you a real time and fast decision making capabilities it has. But in case of human, as we know, like our decision making can be good, can be bad, can be dull. It depends on the way you are adapting information from your teacher, from your environment, from your self learning and all. And the next and the important part is the ethical part, in self-driving car, we all know that it's completely autonomous. But if it does any accident, then it is not liable because it is meeting the ethical part. Like in here in hospital, the robot can do the operation, but if anything happened, it is not answerable because it lacks the ethical part. So, but on the other hand, human brain or human nature is very empathetical. So that is the difference between AI thinking and human thinking. Now, now we will move completely towards AI. So the way AI solve a particular problem is completely search based. Search based means like it is suppose you have a problem and you have a lots of solutions. Each and every problem can have many solutions. So to reach to the actual solution in an optimal way is called search. So the core purpose of search is to optimize decision making by minimizing the cost and maximizing the effectiveness. I will discuss more about that minimizing and maximizing thing. And next, the application can be everywhere. The web searching, like in Google, the robotics, gaming, navigation, everywhere. Basically, you are solving a problem which is a search problem, which is basically you have a point A and point B. Point A is the input, point B is the destination or output. You are going through different states in between point A to point B, and the idea is to reach point B, that is the final destination or the solution, through searching, through go through the optimal and the best solutions. So we categorize that search algorithm in two sections. First is called uninformed search algorithms, and uninformed search algorithms are also called brute force algorithm. It basically, suppose you have a problem to solve, okay, and you are trying to solve it in all possible way, and you are trying, after solving it in all possible way, you are selecting the best way that can be used in practicality. So this way of search algorithms are not that efficient. You can understand. The example is breadth first search and depth first search. And on the other hand, you have informed search algorithms. So informed search algorithms are based on heuristics. So all these terms, the heuristics, optimization, it might sound very, very, tough words, but they are not at all. Like if you go inside it and if you try to understand the semantics or the meaning of it, it's very simple. So the heuristics means certain information that helps you to decide if the solution is good or bad. So there are different informed search algorithms, such as A star search algorithm, based first search algorithms. And with an example, we will try to understand the effectiveness of informed and uninformed search algorithms. So from still now, we are sure that informed from the name you can understand. Informed, that means you are informed with some information for the computation, for the search process. So the informed algorithms are better than the uninformed one. And how it is better, we will explain in that example. So it's a very classic example. It's called traveling salesman problem. It's very easy. Again, from the name, you shouldn't get confused. It's very easy. Suppose you are a salesman and you have your company in different European cities. Suppose you have your company in 10 European cities, any 10 European cities. And your purpose is to start from Luxembourg, visit each and every city, sell some product, and come back to Luxembourg. You are not going to omit any cities in your list, So now, for example, suppose you have companies in all capitals of Europe, like Luxembourg, Paris, Berlin, and so you will go from Luxembourg to each and every city in Europe, or the capital in Europe, and you will sell your product and come back to Luxembourg. This is your problem, and this is called traveling salesman problem. From the name, you can understand that salesman is traveling from city to city and selling their product. But what we need to do, suppose you are a salesman and you have to do that task, what you will do, you will buy tickets, right? You need to go to, first you'll go to the internet and buy tickets so that you can fly from to each and every country. So what you can do, you can start from Luxembourg to Berlin, come back to Luxembourg, then Luxembourg to Paris, come back to Luxembourg, from Luxembourg to any other Brussels, come back to Luxembourg. This is one of the approach. You are going each and every country. But the smartest job, like we human being, what do? We will try to find out the cheapest ticket. We will go there, and from there we will try to look all the cities which are cheapest. We'll go to there, and this information is called heuristic. Suppose I go first to Brussels because I found out that Brussels ticket from Luxembourg to Brussels is the cheaper one. So I will go to the cheapest option. I'll go to Brussels. And from Brussels, I will see all the other cities that I can fly with the minimal ticket price. So this decision is called heuristic. So in the right-hand side, you can see that suppose you have n cities, okay? N cities, and you have a distance matrix. They say distance, we can say the price of the ticket. So it means like here I'm talking about graph theory. In graph, you have vertices, like the nodes, and edges. Edges means those lines that connects those nodes. So it looks like this. In the right side, you can see. So here you have 5 vertices and edges connected to each and every vertices. So you can see from A, you can go to each and every vertex. From B, you can go to each and every vertex. So it is a completely connected graph. That means from a single vertex, you can go to any n-1 vertices that you have in that graph. So coming back to here, so the purpose of the traveling salesman is to find out the optimal route, the shortest route. In our case, the shortest is the cheapest. So we are trying to find out the cheapest route that we follow to solve our purpose. And objective is to reduce the travel cost, reduce the distance. Before, we used to take our car, we used to take our horse. So in that case, the cost is the distance. Currently, we don't take our horse or car. The cost is the travel cost. So that is the traveling salesman problem. Now we will see how the informed and uninformed algorithm, searching algorithm, performed here. So before starting to explaining this, I will give you some idea of how do we evaluate that a searching algorithm is good or bad. There are 2 aspects. There are many, but the most important things are 2: time complexity and space complexity. Time complexity means how long it will take to process the problem. Like I will give an input, I will get an output. How long that process will perform? That is called time complexity. And the space complexity is how much resource do we need? how much data we need to process, what would be the processing power, and all these things, these are called space complexity. So our purpose would be to minimize the time and minimize the resource. Obviously we will try to do that, because we don't want a supercomputer to solve a simple problem. Like, you can solve it if you use brute force or uninformed. You can use a supercomputer. You can see how. We can see how here. So suppose we have 5 cities, okay, A, B, C, D, E. We know the problem is we will start from A and we will come back to A and we will visit each and every city. So in case of brute force, what we can do, uninformed search, you will start from anyone and you can go to n minus 1 cities. So that's why you have n minus 1 factorial. I'm sure that you know what is factorial. Factorial 5 means 4 cross 3 cross 2 cross 1. Okay. Factorial 5 means 5 cross 4 cross 3 cross 2 cross 1. And to calculate all possible roots, we need n minus 1 factorial. That means 4 factorials. So if we use brute force like uninformed search, we have 24 roots. This is manageable, right? For 5 cities, this is manageable. But think of 20 cities, for 20 cities, the possible roots would be 10 to the power 18. And this is called exponential problem. Exponential problems are sometimes infeasible to solve. That means the space complexity will be huge, the time complexity will be huge. But in case of heuristic based search, like informed search, or we can start from A, then B, then D, then C, then E, then A. This decision will be based on certain heuristics, and the searching algorithms will help you to find that optimal route. So what I am doing, I am going from A to B. At B, I am trying to find out the shortest path from B to any other city. So I found out that B to D is the shortest one. I come from B to D, then D to C, and C to E and A. Now here, the time complexity is order of n square. So we generally represent the complexity by order. Like polynomial order means like it will be a factor of n square, n cube, something like that, which is solvable, which is easy to solve. The space and time complexity is reduced. So this is the basic difference between informed and uninformed search. So if you are asked to solve a certain problem, obviously you will go towards the smarter algorithms which are informed, not uninformed. But sometimes we need to go. Suppose when you are analyzing a malware, in malware analysis, sometimes you need to do the brute force approach. You need such things where when you don't have heuristics, when you have no information, you need to do. Suppose you are trying to crack somebody's password. You would not do that. Of course, you would not do that. I am not encouraging you to do that. But the hackers does the brute force approach. They know the length of the password and they try to find out all possible combinations. That is the brute force approach. But it is searching algorithms. They are searching means you are traversing a graph through path to reach a solution. So that's why every problem AI or computer is solving is kind of searching problem. Now, the next slide would be how machine learns. So there are 3 categories: supervised, unsupervised, and reinforcement learning. I'm not going into the detail. I will share the presentation and you can read, but I'm giving an example. So supervised learning means suppose you have to identify. I am giving you a lots of data about cat, dog, and horse, and you need your machine learning thing. Your model needs to identify the cat, dog, and horse. So, but in that case, consider the machine learning algorithm as a black box. And in that black box, we are giving a 1 million pictures of cat. We are telling the algorithm that, look, this is a cat. different cat pictures, but we are labeling it as cat. We are giving millions of dog pictures, labeling as dog, and we are labeling millions of horse picture, labeling as horse. And now we are giving a completely different picture, which is not part of that training set. Training means we are trying to learn that model with giving input. So in supervised learning, from the name you can understand that we are supervising and telling categorically the model that look, this is cat, and try you now your task is to try to identify how cat looks from this all this picture. Now I will give a completely unknown picture which is not present in the training set, and you need to tell me is a dog, cat, or horse. This is a supervised learning. In case of unsupervised learning, there is no such labeling. So in unsupervised learning, we try to find out patterns, and based on the patterns we make clusters. Real life example will be grouping customers into customer base on their purchasing habits. So based on the purchasing habit, Amazon can cluster ourselves. Like suppose I have a kid and I buy kid stuff. I will belong to that category where other parents are there. So based on certain pattern, we categorize, we kind of segment the data set. That is called unsupervised, because we are not giving the level of the data. And now we will explain a completely different learning algorithm which does not require any data. And this is called reinforcement learning. So in this, lecture, we will go deeper into reinforcement learning. In reinforcement learning, is very simple. Like if you try to understand the first day when you went to learn how to drive a car or how to ride a bicycle. So reinforcement learning is inspired by our life, the way we learn. Like when you went to learn a bicycle, it's not the first day you are kind of riding the bicycle, right? You're falling again and again, and you learn from your mistake. Reinforcement learning is exactly works like this way. So I try to understand. Try to understand the reinforcement learning based on question answering method. And I personally believe that if you try to understand some problem, just attack the problem like this way. So in reinforcement learning, you have different building blocks. Building blocks means the main entities that form the entire concept. So in reinforcement learning, from the right hand side picture, you can see you have policies, you have environment, and you have agent, and you have learning algorithms. These are the main components of reinforcement learning. So now read all these questions. So who is the learner or decision maker? An agent. Like who is going to ride the bicycle? You are an agent. Okay. And where does the agent operate or interact? In the environment. Where is the environment? Suppose you are trying to ride your bicycle in the street. You are trying to learn your car in highway. So highway is the environment. And what can the agent do to affect the environment? The effect interact with environment by actions. Actions means like when you are driving a car, turn left, turn right, control speed, speed limit 50, speed limit 100. These are actions. Through these actions, you are interacting with the environment. And what happens to the environment after a certain action taken? So suppose I take the action move right by my car. What will happen? The car will move right. So the car will change its state from the current state to the next state. Current state means it was going straight, and then it will move to right. So in reinforcement learning, you have different states. And the next question, it says what determines the agent's behavior and decision making rules, or what decide what action to be taken. Your driving instructor is sitting beside when you are learning how to drive car. So the driving instructor has a policy. Policy means he knows that, okay, that guy pay for 1 hour, and this 1 hour I will cover that route, and I will go through this lane, that lane, that lane, this lane, and I know how go left, go right, speed limit, and everything. These are the policies. And what is the reward? Reward means after each and every driving session, if you do a mistake, like you cross the solid line, you do a mistake, and your driving instructor will say, look, in next class, since you did the mistake, next class you need to pay me 5 euros. You will never do that mistake because you need to pay 5 euros to him or her again. Then you will say, no, this is unfair. So if I drive completely flawlessly whole day, then you will give me 5 euros. And the instructor said, okay, we agree in that kind of setup. If you do mistake, you need to pay me, and if you are not doing mistake exactly following the policy and the rules, okay, I will pay you. So this is called reward, positive and negative. So through positive and negative reward, the agent learns how to drive, how to solve that problem, interacting with the environment, and what helps the agent learn. This is called learning algorithms, and these learning algorithms helps to update the policy. So what is the policy update? So suppose again, you are a driving instructor, you have 30 minutes left to complete your session, and you are far from the destination. So you have several routes, right? So if you follow there are several policies. Then policies means from A to B, left, right, left, straight. This is one of the policy. But if you take a shortcut like left, straight, it is another policy. So that learning algorithm helps you to select optimize policy to maximize reward. Okay, so that is the sole purpose of reinforcement learning, to design or update policies to maximize reward, to solve a problem in an optimized way. So here, currently in my project, I cannot share the code of this project. And if I share, for sure, you cannot run it for sure. So don't think that, okay, if I have that code, I can run it. So you can, but you need to know lots of things to establish that environment and other stuff. So in that research, currently what I am doing is basically how human and robot are interacting with each other. I am not explaining what I am doing, but here is a toy example how a robotic hand learning to arrange a block, from position 1 to position 2. So here I have a video. I don't know, maybe the video is slow, but when I am explaining, try to look at the video. So here, this is the code I have implemented. I used RoboDK. RoboDK is an environment through which you can interact with a robot visually, like this way. But the problem is you have two position 1 and position 2, and in each position you have 3 blocks. What the robot has to do, robot needs to pick all the blocks from position 1 to position 2 and then return it back from position 2 to position 1. So this is the problem. Okay, and if we need to solve this problem, we are like the way I solved, I use RoboDK for the environment design. Like the picture, that what you are seeing here is RoboDK. Basically the environment is designed using, you can from the title you can see it's called Robot Development Kit. So I designed the robot using RoboDK, and there is a library in Python called Gymnasium. Gymnasium provides you lots of reinforcement learning algorithms, the algorithms I said. And then you have stable baseline 3, which is another library, that provides different learning algorithms. So you can understand right now the objective is to train a robotic arm autonomously to move 3 boxes between 2 positions, from frame A to frame B, and again come back to frame B. Now, these are the building blocks of the program. The first one is the RoboDK simulation. So using RoboDK, I designed the environment. The environment we are talking about, as I said, the agent is the robotic arm. Environment is designed using RoboDK, and the Gymnasium wrapper. So when we are designing some reinforcement learning, we need to find out these three main points. First one is the observation space, second one is the action space, and third one is the reward. Here the observation space means like find out two position in that environment that is effective after each and every execution. These two positions are position 1 and position 2, where we have the blocks, the frame 1 and frame 2. So that's why the observation space is a 2D vector, is an array. At a time, the array can contain maximum 3 blocks. So that is the observation space. And what is the action space? Action space decide the next action you are going to take. So what is the action here? The action is move left or move right. Move the frame up, move the frame down. These are the action, and these are the action space here. And we, of course, the entire reinforcement learning is based on the way you are giving the award or the reward. And here the reward is +1 for valid move, -1 for invalid move, and 10 for completing phase 1. That means moving all the blocks from frame 1 to frame 2, and 20 to finish. That means moving all the boxes from frame 2 to frame 1. The purpose of the robotic hand, the policies would be to acquire as much as award it can achieve, and the learning algorithm is called proximal policy optimization. There are lots of learning algorithms available inside stable baseline 3. You don't need to implement these algorithms. These algorithms are already available. You just need to find out which algorithm is best for your problem. The main thing is the designing the environment and defining the observation space, action space, and reward engineering. Now, if we understand how reinforcement learning works, we will go to the next and the last phase. And I'm not going into the detail of AlphaGo, but can you please turn off your mic? I'm listening to some typing thing. Yeah. So the AlphaGo is a program or a kind of AI model developed by Google DeepMind. I don't know if you know the game called Go, and Go is considered to be more challenging, yet it is very simple. It is very simple to understand than chess, but it is more challenging to solve than chess. It is still that Go is the most toughest mind game. Why? There are several YouTube videos you can learn. I am just giving you an insight. It's like when you play Go, you have like that exponential amount of next move that you can perform. And the purpose of Go is very simple. You have these cross boxes, and you have white and like black dices, and you need to make a region around either the black or the white these dices. So it's basically like a war. You are making a wall around a set of soldiers, and you defeat it. So that is the Go. It's very simple. It's very simple, but as I said, it's very tough. I am playing that video. First listen to it.
When we play the first game, I lose.
I think he was a bit stunned after the first game, and I think he was unsure as to whether he had prepared enough or whether the program was really strong.
I think after first game, maybe he don't like fight. He like play slowly. So it's why begin the second game, I fight. Do mistakes sometimes. I think maybe I'm right. It's why for another game I fight all the time. Now it's complicated. But I lose all my game.
Yeah. So that person is the world champion of Go. He's called. His name is Lee Sedol. So Google DeepMind made that model, and he tried with the champion, obviously the best one, and then he lost all the games, as he said. If it's a big video, you should watch it. I have the link here. You should go there and you should watch how that man felt helpless in front of AlphaMind. So in AlphaGo, basically, the DeepMind use supervised and reinforcement learning. Supervised learning because it collected all the moves from the champions, million of moves. So this is supervised learning because it has level, and then he made games which are playing with each other using reinforcement learning. So it's a combination of supervised learning and reinforcement learning, and is this lethal combination is able to beat human mind very easily. So I will end my talk here, and I am open to discuss right here. You have any question? And this is my email ID, my LinkedIn profile, and my ResearchGate account. You are feel free to write me any queries and questions that I am not going to able to answer this moment. Thank you so much.
Thank you. Thank you so much, Dr. Sukriti, for the nice presentation. Thank you. So we have many questions in the chat. So let's go through them by going to the first one. Thomas, we should go by the first one.
It starts with a technical question.
Yeah. Can you read the question, Dr. Sukriti?
No, I just read the question marks.
This is something we should respond. So you cannot confuse elements of AI with building of AI. These are different courses. So this was just a general question I wanted to point out for everybody.
Yeah, it's only about element of AI.
And then the first content question is by Sam. Isn't the AI creativity limit simply a temporary issue? Like right now, we need to input a prompt for DALL-E to create an image. But what if we simply said, draw whatever you want?
Yeah, I mean, draw whatever you want. You can write it down and you can see. But I didn't understand the exact question. What is the? I cannot read. First of all, I cannot read the question.
Can you read it?
No.
Can you read it, Sana?
Yes.
Yes.
I just read some question marks.
Oh, okay. Then.
So I mean, the question should be visible in the left window, right?
Yes. Yes.
Yeah. I see a close button. I can share my screen. You can see.
No.
No,
I had
it
to.
just
Your screen sharing
you
had to be
stop
stopped
sharing.
in
Yeah,
order
you
for these
stop sharing so
messages.
that you stop sharing so that you can read the question.
Yeah, I mean, it would be great if I can read. Then I can,
Yes.
So this is about AI creativity.
Uh-huh.
So the person asked, what if you ask an AI draw whatever you want? What will
Without
without any kind of limitations?
input.
Yeah. So again, I mean, if the way I will solve the problem is as if I am building the model. Okay, yeah, I'm not talking about any other model like DALI or Mid Journey. The way I will solve the problem is like if you give me the prompt, whatever you want, and then I will ask you another question. I mean, how do you feel today? And you will say, I am very depressed, and then I will draw a flower. This way it's a very interactive way. If you are talking about generative AI, so it means the purpose of the tool should be interactive. So I mean, I cannot answer how DALI will perform. I can answer how it should be performed.
Yeah, it's reactive, but it's not proactive. It cannot suggest, but it can suggest a different topic if it is more smart. But in general, the AI model need a direction. More you give the information, more is it is able to answer.
Yeah.
There's the next question here. Would the paperclip problem be an example of uninformed search algorithm? The
With
paperclip
what?
problem that you mentioned during your presentation, would that be an example of an uninformed search algorithm?
Yeah, paperclip problem.
Yes, paperclip.
So can you explain the paperclip problem first?
It's not my question, so it's something that probably relates to your presentation.
No, in my presentation, I didn't give any paperclip problem. I explained with traveling salesman.
Okay. Uh, we we have too many people to let participants speak at the moment.
So somebody wrote, I think it was traveling salesman. Yeah, I don't know what is paperclip problem.
Maybe we'll wait for the person to respond to that, and then we get the next one by Jose. I understand that an array of routes should be created. If so, what functions and/or method does it use to achieve the shortest route?
Yeah,
This
so
was
so that is the heuristics, what so there are different searching algorithms like A star algorithms. So you need to understand all those algorithms, the way they are optimizing the search space. There are lots of, so that is the purpose of those algorithms, to give you the shortest path.
okay. We have an answer from Sam. The paperclip problem is a thought experiment where an AI is given options when to decide either to kill all humans in order to create more paperclips.
Okay, I am not aware of that problem. I need to understand that problem first.
I don't understand that either.
Yeah.
Okay, maybe in the forum then. There's a question again. I understand that you need to create a matrix of path. Otherwise, I think this is the same one from before. There's a question by Daniele. I don't understand this reward concept for an algorithm or AI model. Isn't it sufficient to tell that it is right or wrong, or it could be better to do so? Reward seems like a human need or culture. I don't get it for AI.
Yeah, of course. So it's like, you need, suppose you need to perform certain task, and the task can be done right way and wrong way, and so you are repeatedly trying to follow that step again and again, and after each and every step you follow, I am telling you, look, you did the right thing, or look, you did the wrong thing. So suppose you perform that action 100, 1000, 1,000,000 times, and then you will try to you will have an idea, like as an human, not talking about AI, as an human you will have an idea what is right and what is wrong, and that is the purpose of reward. Purpose of reward means somebody is guiding you towards the actual solution, giving you chocolate, giving you money, giving you coins and anything for doing right thing, and taking something from you for doing wrong. And if you repeat it again, so you know that, okay, so if you know how to earn more money, that means if you want to earn more money, that means indirectly you are doing something good, or you are learning the situation more accurately. That's why you are giving money. So that is the philosophy behind that reward.
Yeah. I can add something because the principal concept is right or wrong, but how the machine can make difference between right and wrong by using the reward. So without the reward, machine cannot recognize what is wrong and what is right. Yeah, exactly.
Somebody wrote, is reward like the carrot in front of a donkey? Of course, and a stick. Like if does something wrong, on his back, that is the penalty. So if you ask the donkey to, okay, so go from here to there, and then you will get a carrot. Otherwise, I will spank you. Then of course after 10 days, the donkey will go towards carrot, not toward the spanking. So that is the idea of reward.
There's the next question here. Why do you need learning for this? So this person is talking, Jean is talking about the robot's movement. He writes each robot's movement is a translation or rotation represented by 4 times 4 matrices. The starting and end positions for each block are known. You just need to calculate the translations and rotations. Isn't that it?
Now you are talking about only a single hand and 3 blocks, right? Of course, you can, if you are writing a program, you can write a for loop, if then else conditions, and you can perform that thing. But suppose you have a complex situation where you need, you have a different complex environment, and in that case, that straightforward way is not applicable. I mean, to answer your question, if we can solve all this problem like this, even we don't need machine learning, right? We don't need anything, we just can write something with we know. Suppose we want to solve a problem, we know all the possible solution, we model everything in hard coded way, and we are giving you something with, as you said. But in machine learning, we are exploring the search space to give you the optimal solution. So the way you said, of course, you can do that. Maybe one hand robot, 2-hand robot, but there will be a limit where you cannot. And during that time, you need machine learning or reinforcement learning.
And the next question goes exactly there, a little further. So what's the difference then between learning and programming in this case, in this example?
Yeah.
So,
Yeah. So for me, learning is a kind of conceptual part, So you are training a AI model means you are kind of giving that model brain, and that brain is nourished through learning, through data. And you can, and the way the entire thing is done by program, so I know the theories and I want to apply those theories to a practical implication. So that is the slight difference between learning and programming. So if I want to incorporate learning inside the model, I will do programming, and when the model is learned, and then I will say, okay, it's now the model is programmed, it's ready to answer your queries,
Yeah, I can also add something about the difference between programming and AI. So the programming is just you have a rule and you need to build your instruction line by line. You have a rule to develop, so everything is clear. But in AI model, you don't have the rule, but you have a data that you need to build the pattern and to make your data understandable for the model to be able to understand what to do. So by showing experience, example of historical data or of the past, the data is able, for example, to predict what will happen in the future. So by this way, we teach the machine how to do prediction by looking to the experience in the past, but we don't give any rule. Yeah.
Yep.
There's another question here. Are you familiar with the Tower of Hanoi example?
Yep.
And in the context of reinforced and supervised learning, could you try to explain on this example again the difference between reinforced and supervised learning?
Okay, so first, if you look at my example, the way the robotic arm was arranging the boxes, I can easily kind of transform that to Tower of Hanoi. It's like there are 3 poles, and you have the different. If no, there is 1 pole, right? And then no, three. Tower of Hanoi, and then you just arrange ascendingly the plates on the pole, that is Tower of Hanoi. And for reinforcement learning, I can define in my case the action space will be 3 position. And if I have 3 plates on each tower, then suppose in that example I have 3 blocks in each position, and I will assign size of the plate like 3, 2, 1. So none of the plates of 3 can be placed on 2. So I will keep that ascending logic in reinforcement learning, and if any of these logics got violated, there will be a penalty. And if you perform all this placement properly and all these moves, then you will get positive reward. That is the reinforcement learning. But in case of supervised learning, I will categorically label each and every disk is like, okay, so this disk is the bigger one, this disk is the smaller one, and I will give a picture of a solved problem into the system, that look, your solved problem, when you solve the problem, it should look like this. So if we try to convert that Tower of Hanoi to supervised learning, I will do like this way. There are several models like CNN and all. So what I will do, I will take the final solution picture, because it is a visualization stuff. So I will give like arrange all possible ways. You can, I will generate different layers of neural network, arrange all possible ways, but the final output should look like this: 3, 2, 1, not 1, 3, 2. So this is the way I will try to solve. I will guide through example how the final output is going to be looked. And in reinforcement learning, I will guide him step by step what is wrong and what is right to solve this problem.
Okay, thank you. There's a question that relates here. So the person is Emmanuel, seems to still be confused about supervised and unsupervised learning and this reinforcement learning. So is there only supervised, unsupervised learning used to train AI as such?
No, I mean, that's what I'm saying. So reinforcement learning is a special learning where you don't need to collect data. It generates its data. Like doing mistakes and doing right thing. Supervised learning means you are supervising the model. So supervised learning, from the machine learning perspective, supervised learning is the easiest learning. So you are telling, look, this is cat, eat it. Look, this is dog, eat it. And then I will give you a food, because you ate cat and dog before. How cat and dog taste like. Now you tell me, oh, look, this is cat or this is dog. This is supervised. But in reinforcement learning, I am not giving you lots of videos to look at how to ride a bicycle. I will give you a bicycle and kick you out from my door and put you in the road and learn by yourself. You fall, you learn how to balance. So this is called reinforcement learning. Reinforcement learning doesn't need any prior data to learn. It learns from life. The way we learn with like both reinforcement and supervised way, even unsupervised way as well. In unsupervised, there is no leveling. For an example, in a classroom, there are different students available, but their height is different. So I will make different classes. I will say from 4 to 5, I will put one group. From 5 to 6, I will put another group. And 6 to 7, I will put another group. So I am not labeling, just looking at the data and how close they are with each other. I will put them to a proper bucket. And that is called unsupervised learning.
Yeah, I also have another example which I like. Supervise it. It's like you have your teacher that is showing you the picture of animals that you can classify by name, and unsupervised it is that you don't have this teacher and you are learning by yourself the picture without knowing the name. And reinforcement is that like you are bland in an environment, but you need someone to tell you what if this action is good or not.
Yep.
That's it. Yeah.
There's a little different question here. Can you name some algorithms used to find the shortest path? In chapter 2 of their MOOC, they learned
Yeah.
about the min-max. Which other algorithms can be used?
Yeah, even if you go through the slide, you can find the names are already given there. For A star algorithm, first search algorithm, and these are informed and uninformed was breadth first, depth first. There are lots of Dijkstra algorithm, Floyd algorithm. There are lots of. Just go to Google and type any search algorithm, and you will get hundreds.
Is there they now we have questions that go further into contextual. Is there a clear distinction between the fields of machine learning or statistical learning and operational research?
I mean, for me, like if you ask me, different people can answer differently. But for me, machine learning is nothing but statistical learning. I mean, for me, it's we can name it different way, but if you go into the mathematics and if you go detail, you will find the old statistics and old that traveling salesman problem is an operation research problem, like we used to do in operation research. So I mean, it would be wrong for me to discriminate, AI scientist, statistical scientist, and operation research scientist. I mean, if you are an AI scientist, you should respect and you should accept that AI is not coming from the air. Artificial intelligence is coming from the old mathematics and old statistics that we have learned. So that's why there are two categories. I mean, again, it's my thinking. There are two categories who thinks AI as a black box. They don't want to understand what is going on inside. They just give input and get output. And another category who works like in least we work in explainable AI part. Like we try to understand why this model is performing like this way, and that is completely impossible if you don't understand statistics or operational research, integer problem related mathematical foundations.
All right, thank you. I just asked people to reiterate a question that's there's still a longer question here. One sec. By René. AI is, per my understanding, a beauty contest based on a winner amongst a list of participants which took place on a given date and time. How can we humans have confidence in the trustful outcome if the environment from where the data is retrieved or where the learning occurs might be biased?
Yeah, so that's why I'm talking like you need human in the loop, and there are a problem. Classic problem is called class imbalance problem. So suppose you are talking about supervised learning, and just think of it. I want to discriminate between cat and dog, okay? And I gave you 1 million cat pictures and 100 dog picture for training, okay? And then I give you a dog and tell me what it is, a cat or dog. There is a huge probability that the machine will tell it is a cat, because machine knows. It's a very classic problem. You can search in the internet about Tesla. It happened. It's a real world problem. It's happened. It's like in when Tesla was built at the beginning, they were crashing the black people. I mean, it may sound harsh, but it was true. It was because the data set, the image detection data set, was trained with white people. So that's why it was not distinguishing black people as human, and there was a lots of obligations from human rights and other stuff. But it's a classic problem because there is a class imbalance one. So in your case, for a beauty contest or any contest or anything, the you need to find out first. So that's why when you model a problem, there is a part called data engineering. So you need to select the or filter the best data for your model. Otherwise your model will be biased. Otherwise your model will give you wrong answer. So that's why you need to be selective about the selection of the data before you train your model.
Okay, so one more question, Thomas.
Yes, there's a short question here by Shashi. Is there any check and balance mechanism to remove any biases internally put during the supervised learning?
Of course there are lots of course. I mean, this is very. So just think of like this, like what the problem you said, it's the first thing that will come to my mind, why I will trust AI, so that's why, there are lots of such problem that will tell you if there is any bias or not, when you are going into your next class, you will learn about deep learning and other stuff. You can, through different statistical approach, you can tell that okay, the data is biased, or the result it is giving, support it gives the accuracy as 99.99. So then you will have doubt. Let's go deep into the data. There are lots of tests to check if it is kind of biased or not. There are lots of, yes, of course. Just Google, you will find lots of.
Then we have one last question, and this is a longer one still. A test was done in UK. Two AI were showed pictures with dogs and cats, and the need to learn to identify which animal is a dog and which animal is a cat. Every picture containing a cat was showing a human keeping the cat in the arms. When it was showed to the AI, a picture with a human keeping a goat in the arms, the AI answered it is a cat. What algorithms should be applied to correct this error this identification error? A
Yeah,
supervised or
yeah.
reinforced one?
I mean, I would not go for reinforcement learning to identify a goat. So it's what I would do. I would add more goat pictures,
Exactly.
into the data set, to make that AI model the look, don't act like a goat. So there is a difference between cat and goat. So
Yeah.
give more data as goat, and then for sure that model will identify a man holding a cat, or
Yeah, sometimes it's not the algorithm, but the size of the data you provide to to the algorithm. Yeah,
exactly. That's why you need to find the path is like first the filtering and data engineering, and then applying that
mhm,
data to the modeling. Otherwise, it's a waste of time.
exactly. So unfortunately, we cannot go through all the question. Thank you, dear speaker, for taking the time to give a talk and to answer the